All right, so we got two complicated problems today. First one's not going to be bad. Second one's going to be really bad. And hats off to all you who are gone today. Optional Tuesday, so we hope to see you when you get back. After robbing a bank in Dodge City, robber gallops off at 14 miles an hour, probably his horse, right? So we're back in the Old West. 10 minutes later, Marshall leaves in hot pursuit at 16 miles an hour. How long does it take the Marshal to catch up with the bank robber? Well, hopefully you understand right away by seeing this that this is a rate is equal to distance divided by time problem. But it's different than the one we saw yesterday. Because the one we saw yesterday, the two planes were headed towards each other. These are not headed towards each other, are they? Nope, we have this bank. And we have the robber galloping off on his horsey at 14 miles an hour. Marshall leaves 10 minutes later. Why? I don't know. Maybe he wasn't notified right away. Maybe he was busy drinking his coffee. I don't know, but he left 10 minutes later. Maybe he was very confident that he had the faster horse. Who knows? He leaves at 16 miles an hour. Now, my question to you is this. Are you convinced that at some point the Marshal will overtake the robber? It might take an hour, might take 2, might take 5. It might take a couple trips around the globe, but at some point, the Marshal will overtake the robber. Okay? So let's think back to yesterday. Who was our volunteer yesterday that helped me out? Logan was. He started walking towards me, right? Like we were the two planes ready to crash. And the question is, what remains the same? So look at this situation here. Is the rate the same between these two people? Thank you. It is definitely different. One is 14, one's 16. Okay. Will they have traveled for the same amount of time? No, they won't. The robber will have always traveled for 10 minutes more, correct? Will they have traveled the same distance? Yeah, that's what it means. One overtakes the other. So when are their distances the same? So that's why I decide to solve for distance. Rate times time is equal to distance. So in other words, we'll say when is the robber, I'm sorry, we'll start with the Marshal. Marshal, is Marshal with 2 L's? Who knows? Marshal distance equals robber distance. Well, I will write an expression for the Marshal distance. The Marshal distance, as said by our formula, is his rate times time. What is the Marshal's rate? So 16 times t. What is the robber's rate? 14 times t. Except we've left out one very important part to the problem. What have we left out? Yeah, the fact is that there's this 10-minute head start. Now, we're talking about distance with this expression. Is 10 minutes a distance? No, we need to add on a distance. How do we calculate distance? We take the rate times the time. What is his rate? 14 miles an hour. What is his time? 10 minutes. But our rate is in hours. That's a problem. So would you like to convert all the rates to minutes, or would you like to convert the 10 minutes to hours? 10 minutes to hours. 10 minutes is how many hours? 1/6. So you can see that this accounts for his head start. Or in other words, we have 16t is equal to 14t plus the 7/3 or 2.3 miles head start. That tells us the head start that he received. Now we solve the problem. Quite simple. We subtract the 14t. We get 2t is equal to 7/3. When you see fractions, your brain goes to mush. So instead of dividing by 2, multiply by a half. We get t is equal to 7/6. 7/6. So that's 1 1/6 hours. Or 1 hour and 10 minutes. Now, is 1 hour and 10 minutes, is that the time at which the marshal has been traveling or the time of which the robber has been traveling? Which one is it? How are you so sure? Okay, so you can see if Asher looks back at the problem, what he's considering is if you take this 1 hour and 10 minutes and put it right there, it says the marshal is talking about 1 hour and 10 minutes. However, if you take the 1 hour and 10 minutes and put it here, fine, the robber is 1 hour and 10 minutes, but we also have that 1/6 right there. So you can see that we have 1 hour and 10 minutes, but here we have 1 hour and 10 minutes plus 10 minutes, or an hour and 20 minutes. So you can see the way that you set up the problem tells you the solution. There are multiple ways of setting this problem, probably about 4 other ways. I'm just going to show you one, and to me, that's the one that makes the most sense. We okay with that? Okay, flip it over. Cross off what I crossed off and write, it says a boardwalk is parallel to and 210 feet inland. Write that, and I got to pass this sheet of paper out quick. Last problem in this unit. This is a tough one. Fortunately, you guys are extremely intelligent. Just think how difficult it would be if you weren't extremely intelligent. We have a boardwalk. It's parallel to and 200 feet inland from a shore. We have 210 feet there, and I have the water. Why would you be walking on a boardwalk? Anybody? Why would you walk on a boardwalk? Have you ever walked on a boardwalk before? Have you been to the ocean? So why would you walk on a boardwalk? What else would you walk on? Why not walk on the sand? Shoes could get dirty. It's harder on your knees. Water could come up too close to you. Might step on jellyfish that came in with the tide. All sorts of information. Okay. All right. So we've got the water there. Sandy beach lies between. Man is standing on the boardwalk. So we have a man. He's got a long neck. He has no torso. And he is exactly 750 feet across the sand from his beach umbrella. So we've got an umbrella over here. He's trying to get to his umbrella. He's vacationing. Okay. And that distance is 750. Cool. Everybody okay with the drawing thus far? All right. Man walks 4 feet per second on the boardwalk, 2 feet per second on the sand. How far should he walk on the boardwalk before veering off onto the sand if he wishes to reach his umbrella in exactly 4 minutes and 45 seconds? Oh, boy. So he's going to walk for a while, and then he's going to veer off. So we have some distance on the boardwalk and some distance on the sand. We want to know how far he should walk on the boardwalk before veering off so that the total amount of time is 4 minutes, 45 seconds. So somebody tell me, let's just admit the obvious right now. YouTube, we're going to digress for a second, talk about how stupid the problem is for a little bit here, okay? So what makes this problem dumb? All right, YouTube, we just talked about how ridiculous the problem is, but we understand why we're asking and how we're going to build on it in the future. So here we go. So does everybody recognize that this is a rate is equal to distance divided by time problem? So there's something that really drives the problem, and that's this 4 minutes, 45 seconds. Is that the distance, the rate, or the time? That's the time. And we know that the time is constant. So therefore, what I want to say is his time on the boardwalk plus his time on the sand must be equal to 4 minutes and 45 seconds. Now, because our rate is in seconds, how do I convert everything to seconds? So 4 minutes and 45 seconds is how many seconds total? 4 minutes is how many seconds? 4 times 60. 240, so yep, so 285 total. Good. All right, well, at least I got an equation that can maybe help me out. Now I got to figure out an expression for time on the boardwalk. Well, this tells me rate. It doesn't tell me time. If I multiply both sides by t, I get RT is equal to D. And if I divide both sides by R, I get T is equal to D divided by R. So it looks like if I take his distance divided by his rate, that's the time. What variable do we have written down for his time or for his distance on the boardwalk? B. What is his rate on the boardwalk? 4. Plus, what's his distance on the sand? S. What's his rate on the sand? Not bad, huh? We got two variables. We need one variable. A little complicated. Fortunately, you're extremely intelligent, so we'll be able to figure this out. I call this X. And we're going to write B and S in terms of X. Anybody figure out, well, I don't know B, do I? Could I figure out this entire length? How? I've got B plus X, that quantity squared, plus 210 squared is equal to 750 squared, right? Don't I have a right triangle going on? So what I'll do is I'll take that 750 squared and I will subtract the 210 squared and I get that. And if I square root the answer, I get 720. So this entire distance here is 720. So we did this yesterday, A for the day. How can I write B in terms of X? If this whole thing is 720, and this is X, then B is 720 minus X. Very good. So I have 720 minus X over 4 plus, okay, now I got to do the same thing with S. Anybody see a relationship that exists with X, 210, and S? Pythagorean theorem again, right? In other words, X squared plus 210 squared is equal to S squared. What would I do to both sides to solve for S? I have an S squared. What would I do to solve for it? Square root both sides. And so you end up with S equal to the square root of X squared plus 210 squared. Can I take the square root of the X squared and the square root of 210 squared? Or is that illegal? Can I just write this as X plus 210? I can't. Because it's addition. If there was multiplication, I could. So we have an expression for S. S is the square root of X squared plus 210 squared divided by 2 is equal to 285. So that's the magic. There we have it. Now we got an equation with one variable. Now it's just a piece of cake. We solve it. Fortunately, you guys are really good at solving algebraic equations. I'm going to pretend like I have no idea what's going on. You guys are going to guide me through the process. Where do I even start? What do you want to do? Okay, what is the common denominator? 4. So I should multiply through by 4. Now I'll get rid of the fractions. Great idea. I like the way you think. That'll give me 720 minus X plus, then what? 2 roots of X squared plus 210 squared. And then I have 4 times 285. Let's see, that would be 570 times 2, 1140. Very good. Okay, looks like a little bit better. Now what? if you have a square root, what are you going to eventually have to do? Square both sides. Would you like to square it right now, or would you like to do a little bit of work first? Okay, let's move the 720 over to this side, and let's move the x over to this side. So we have 2 roots of x squared plus 210 squared is equal to 1,140 minus 720 is 420. We add the x to both sides, and there we have it. And the giggles go every hour. All right, now what do we do to both sides? Square it. If I square it, I got to take 2 times 2 is the 4. What happens to the square root? Goes away. I got the parenthesis x squared plus 210 squared equals, oh boy, I got to FOIL that out, don't I? So I got 420 plus x times 420 plus x. So that'll be 420 squared plus, everybody know what's going to be in the middle? I have 420x and 420x. This could be 840x. And then I have x squared. Looking better, huh? Ooh. All right, let's distribute the 4. 4x squared plus 4 times whatever that thing is. I don't even know, but we'll deal with it later, I guess. What degree of an equation is this? First degree, second degree, third degree, fourth degree, second degree. Yeah, it's a quadratic. We know how to solve those. Zero product property, right? Get everything on one side, factor, or use a quadratic formula or something. So let's just move it on over. 4x squared and x squared is going to make 3x squared minus 840x. And then I got to take 4 times 210 squared and subtract 420 squared. Let's see what we get. We got 4 times 210 squared minus 420 squared, and I get, oh, what are the odds of that? We'll take it. Cool. Gone. Is that factor? Is 840 divisible by 3? What is 8 plus 4? Plus 0? Is 12 divisible by 3? So therefore 840 is divisible by 3 as well. We take out the 3 and the x. 280. What are the solutions to this equation? Let's bring it all the way back up to see what it exactly means. I locate x in the problem at 0 and 280. Let's now think about it in context of the problem. The problem says, how far should he walk on the boardwalk before veering off? So if x was 0, how far should he walk before veering off? Remember, b is 720 minus x. So if x was 0, how far would he walk? 720. So 720 feet. So if he walks the entire distance and then, veers off right at the end, that'll help him arrive in exactly 4 minutes and 45 seconds. Or if x is 280. So if we plug in 280, 720 minus 280 is 440 feet. And that will help him arrive at exactly 4 minutes and 45 seconds. Super challenging problem. But a problem that you are capable of doing, that I've seen people work throughout the years. I'm excited to see your work as you work through it. So, YouTube Nation, there you go. Have fun with that one.